Welcome, explorers of our planet's most profound secrets. Today, we journey to the ends of the Earth, to a land of ice and colossal beauty, Greenland. But beneath its majestic frozen facade, a hidden force is at work, silently accelerating a global crisis. Imagine waves, not on the surface, but deep underwater, towering as high as skyscrapers, relentlessly eating away at the very foundations of our world's second largest ice sheet. This is the astonishing story of the massive hidden waves melting Greenland's glaciers. Greenland's ice sheet is a behemoth, covering an area roughly 40 times the size of Switzerland. It holds enough frozen water that if it were to melt completely, global sea levels could rise by about 7 meters, or roughly 23 feet. For decades, scientists have known that Greenland's glaciers are retreating at an alarming pace, contributing significantly to rising sea levels. The Arctic, in fact, is warming 4 times faster than the global average, a phenomenon known as Arctic amplification. But what was driving this melt so intensely, particularly from below? The visible drama of calving glaciers, where colossal chunks of ice break off and crash into the ocean, is a well-known spectacle. These events create surface tsunamis, churning the upper layers of the fjords. For a long time, the full extent of their impact beneath the surface remained a mystery. The conditions in these ice-filled fjords are treacherous, making direct observation incredibly difficult and dangerous. Satellites, while invaluable, can only see the surface. Until now. In a groundbreaking effort, an international team of researchers from the University of Zurich and the University of Washington, among others, embarked on an ambitious expedition. They deployed a 10-kilometer-long fiber-optic cable along the seafloor of a fjord at the Ekelerutset-Kingillit-Surmiat Glacier in southern Greenland. This particular glacier is a true giant, releasing approximately 3.6 cubic kilometers of ice into the ocean each year. That's almost 3 times the annual volume of Switzerland's Rhone Glacier. Using a cutting-edge technique called distributed acoustic sensing, or DAS, the cable acted like an underwater ear, detecting tiny vibrations and temperature changes. And what it heard was astonishing. It turns out the surface tsunamis are just the beginning. After the initial splash subsides and the surface appears calm, another, more insidious force takes over: massive, hidden underwater waves. These internal waves are nothing short of incredible. They can reach heights comparable to skyscrapers, yet are completely invisible from above. Here's how they work their destructive magic. Greenland's fjords are layered. Colder, fresher meltwater from the glaciers tends to sit atop warmer, denser, saltier seawater that flows in from the deeper ocean. When an iceberg calves, it doesn't just create surface disturbance, it triggers these internal waves that propagate along the boundaries between these different density layers. These skyscraper-sized waves relentlessly stir the water, a process that continues for hours, even days after a calving event. This constant churning pulls the warmer, deeper ocean water upwards, bringing it into direct contact with the submerged face of the glacier. This warm water acts like a subaquatic blowtorch, causing significant seawater-induced melt erosion at the glacier's base. It literally eats away at the ice from below, undercutting the glacier and making it even more unstable, leading to more frequent and larger calving events. Scientists call this the calving multiplier effect, a vicious cycle accelerating ice loss far more than previously understood. The implications of this hidden melting mechanism are profound. Greenland is already losing an astonishing 234 billion tons of ice per year, a rate 7 times faster than in the 1990s. This accelerated ice loss directly contributes to global sea level rise, threatening coastal communities worldwide. Furthermore, the massive influx of cold, fresh meltwater pouring into the North Atlantic can disrupt vital ocean currents, such as the Gulf Stream, with potentially significant consequences for Europe's climate. Beyond the visible ice loss, scientists are also discovering other alarming phenomena, such as subglacial lakes, whose meltwater can burst through the ice sheet surface with immense force, carving massive craters and further destabilizing the ice. For example, in 2014, a single subglacial flood released 90 million cubic meters of water, equivalent to about 9 hours of Niagara Falls peak flow. This new understanding of massive hidden waves reveals just how fragile and interconnected our Earth system truly is. It underscores the urgency of addressing climate change not just from surface warming, but from the complex, unseen dynamics happening deep within our oceans and beneath our ice sheets. Thanks to innovative technology, we are finally getting a clearer picture of these critical processes, arming us with the knowledge needed to better predict our planet's future and perhaps to safeguard it. The battle for Greenland's ice, and indeed for our world, is a battle against the seen and the unseen, a battle we must understand if we hope to win.